Hi, geometry guys. Welcome to Unit 5. This is going to be notes for Lesson 5-1. We're talking about triangle mid-segments. So we'll just go ahead and jump in. As you guys are watching the video, please take notes in Notability. So a triangle mid-segment is a segment connecting the midpoints, hence the name mid-segment, of two sides of triangles. An example in the diagram we have over to the right would be segment DE is my mid-segment. If you notice, DE connects the midpoints. I know it's midpoint because I can see I have my congruent marks. BD is congruent to DA, so that means D is the midpoint. BE is congruent to EC, so I know that E is the midpoint. So altogether, this segment is my mid-segment. So a mid-segment has some special properties. We're going to take a look at our triangle mid-segment theorem. This is kind of our news for the day. And it says that if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half as long. Now, in my picture, this AC would technically be my third side of the triangle. So using the diagram above, if DE is a midsegment of ABC, then I would know a couple of things. I would know that AC is parallel to DE, and I would also know that DE is half of AC. Or if you flip that formula, AC would be twice times DE. So we're going to go ahead and play around with this a little bit and take a look. Number 1 says identify all pairs of parallel segments. So one of the things I see is that X is a midpoint of QR. I'm just going to highlight things corresponding here. And I know that Y is a midpoint of RS. So that means that this segment, QY, would be a mid-segment for this triangle. So XY. So XY is going to be parallel to QS. But I could look at it a couple of other ways. So I'm going to kind of erase this. And then I could also say that XW could be a mid-segment, right? Because that's a midpoint, that's a midpoint. So that could be parallel to RS. So we could have XW parallel to RS. And then you have a third mid-segment in here. You've got WY, because W is a midpoint, Y is a midpoint. So WY could be parallel to QR. All right, we'll take a look at number 2. I want you guys to take a moment and try that for me. See if you can come up with all the pairs of parallel sides. So hopefully we got JK is parallel to FH. Oops. There we go. FH. I could have that JL is parallel to GH. Oops. And finally, I could say that KL is parallel to GF. All right, let's go ahead and try to find some missing sides now. Okay, number 3, it says if L, M, and N are midpoints of the sides of triangle PQR, If PR is 46, so I'm just going to kind of write this down here. That's 46. P to Q is 40. And L to N is 17. Find each measure. Okay, so for starters, it wants me to find LM. So LM is right here. That's going to be parallel to PR. Well, the triangle mid-segment theorem says that that third side is half as long, or the mid-segment is half as long. So if PR is 46, that means that LM is equal to half of PR. So LM is going to be half of 46, or 23. And I'm going to mark that on my figure. Okay, the next one I'll need to do is MN. So if I take a look, I've got MN is going to be parallel to PQ. I'm going to use that triangle mid-segment theorem once again. MN is going to be half of PQ. PQ is 40. Half of 40 is going to be 20. Next, I have to do QR. So QR is going to be associated with the mid-segment at LN. LN is the mid-segment. QR is the side parallel. So we could do that same theorem, LN equals half of QR, or you could do 2 times LN equals QR. Now the way I'd get that would be times 2 times 2, that gets rid of your 1/2. So 2 times 17 is going to be QR. That's 34 equals QR. Last one is MR. So to get MR, remember this point M is the midpoint. They told me that that's the midpoint. That means QM is the same as MR. So really all I need to do is divide. Well, we kind of just did the work right over here, guys, that the mid segment is going to be half. So half of 34, that's kind of what you started with, would be 17. So that's 17 and that's 17. Okay. If we take a look at number 4, same kind of thing. So F, G, and H are my midpoints. F, G, H are the midpoints. If you wanted to, you could mark in your congruent pieces. That could be helpful. Okay. F to G is 9. G to H is 7. And C to D is 10. Or sorry, 24. Find each measure. So starting with CE. Okay, I'm going to kind of again highlight it out. So CE is going to be parallel to GH. That's the mid-segment. So one way you could do it is you could just do 7 and 7. It's basically going to be double the side of the triangle. So C to E is going to total out to be 14. DE, again, if I highlight out my sides, DE is going to be parallel to FG. So I see that this one is 9. That means that's 9 and that's 9. Or double 9. 9 times 2 gives you 18. FH is associated with C to D. You see C to D is 24. If I cut 24 in half, I get 12 and 12. I can do that because, again, G is the midpoint. So half of 24 gives me the 12. That means FH is 12. Okay. Now, one thing that we haven't discussed is perimeter. Perimeter would just be adding up all my sides. So I would just be adding up C to D plus D to E plus E to C. So it's going to be 24 plus 18 plus 14. That's how we're going to get that perimeter. So we add up all the sides and it comes out to be 56. Moving on, we're going to do a little bit of stuff with algebra. So again, we're still using that same triangle midsegment theorem. So I've got my midsegment, which is 7x. I know it's the midsegment because I see my congruent marks here and here. So that midsegment, 7x, is going to be half of 17x minus 18. So we start with the equation. Instead of distributing this, I'm not going to do that because then I'm going to have half of 17. That's not going to be fun. I'm going to do times 2. 1 half times 2 cancels out. On the left side, 2 times 17x, we have 14x. Now I can go ahead and solve this one. So I'm going to do minus 17x, get the variables on the same side, and then divide by negative 3. So we get x equals positive 6. And that's all this wanted you to do. Find the value of x. I don't need to plug anything in. We'll take a look at number 6, same thing. So once again, it's giving me the midsegment. I know that it's parallel to that third side of the triangle. I see my congruent marks. That's how I know it's a midsegment. So my equation, midsegment equals half of that third side of the triangle, or the side it's parallel to. This also gives me that weird situation where it's like I don't really want to do, sorry guys. I don't really want to do half of 19. That'll be a decimal. So instead, I'm going to start by just doing times 2. And we have to do it like this on the other side. Put parentheses around all of that. So over here, we'll have 12x plus 62. On the right side, the 1 half cancels out. And now we go through and we solve. I'm going to bring the baby to the mama. Divide by 7. Sorry, I'm just going through the algebra steps. You guys know this. And you should get x equals 14. All right. So in taking a look at the next thing that we have, it's going to just involve more algebra, but still using the exact same theorem. Okay, so for 7 and 8, I'm going to have you guys take a moment and try those. Mid-segment, parallel side. So I'm going to do 2 times DE is going to equal AB. Go through, solve this one. Bring that baby to the mama. And the x is 9. But this question is a little bit different because if you look at the directions, they want me to find DE. So now we have to plug it in. So DE is 4x plus 1. I'm going to plug that 9 in. So I get 36 plus 1, or 37. So it's a little bit different than 5 and 6 that we just did. We now need to find a missing side. I'm going to do the same thing for number 8. So you've got your mid-segment. You've got the side parallel. We're going to use that second formula. The 2 times PQ is going to equal RT. So 2 times 15x minus 17 equals 23x minus 6. This, truthfully, I've talked to you guys about things like this before. If you could set this up, that's like really what we're learning in this lesson. The rest is solving an equation, which you guys know how to do. Bring the baby to the mama. I get x is 4, but again, they want me to plug it in. So RT is 23x minus 6. So as I go through to plug that in, I get 86 when it comes out. So 86 is technically the answer on this one, not 4. All right, let's take a look at a couple of other things. It's just more problems using this theorem, asking for different things. If we look at number 9, MN, NO, and MO are the mid-segments. Find the perimeter. Okay, so we are definitely going to need a little bit of algebra here. I'm going to kind of start with some of the easier pieces. So if M to N is 49, I know that that's 49 and that's 49. And I could add that together, 49 plus 49, or do 49 times 2 and get 98. I'm also going to do that for this side that we know. NO is 42. So I know on this side, this one would equal this one, 42 and 42. And we can go ahead and add that together. 42 and 42 is going to give me 84. Now, unfortunately, we have a little bit of work to do here because this mid-segment is 6x minus 1, and we know that that's going to be associated with this side, KL. So we're going to do 2 times 6x minus 1 equals 13x minus 10. Let's go through and solve. So we get x equals 8. And I'm going to need to plug that in. The side I need to find is going to be this side, this KL. So I'm going to plug it into that 13x minus 10. So 13x minus 10, we're plugging in 8. And you should end up getting 94 when you do this. So this side is 94. So to get that perimeter, we're adding all 3 sides of the triangle. So when I go in, I'm adding my 94, my 84, and my 98. And when you do that, it comes out to be 276. Okay, now we're going to have some things with angles. So let's take a look. We have to kind of draw back to some of the things that we've already learned. So we'll take a look here at number, 10. All right, so we need to find all of these angles. We've got these congruent sides, which is great. But remember, we know some things are parallel, yeah? So this one is the mid-segment. I know it's the mid-segment because I see my congruent tick marks here and here. So I know that these two guys are parallel. Well, let's start with kind of like the easier pieces for us. Let's get a linear pair. So between 127 and 2, that's a linear pair. So we can just do 180 minus 127 and end up getting 53. So I know that angle 2 is 53, okay? From there, I've got to figure out some of my things with parallel lines. So if I had my 2 parallel lines, and I'm going to kind of really exaggerate that to make them like actual parallel lines like this and this. And if I thought that this was the transversal, well, one of the things I know is that angle 1 and angle 2, those are going to be my corresponding. Angle 1 and angle 2 are corresponding. They're both on the same side of the transversal and they're right underneath the parallel line. That means angle 1 is 53. They have to be congruent. So now I'm going to do the same thing on the opposite side. And I'm going to think, okay, well, if this guy is my transversal, then I would know that 59 and 4, they are going to be corresponding. So angle 4 has to be 59 degrees. And if I can get angle 4, I can get angle 5. That's a linear pair. So 180 take away 59 ends up giving me 121. So that's going to be angle 5. And then I can get angle 3 because I have inside here, we have a triangle. So we know that all 3 angles of a triangle have to add up to be 180. So for my last little step, I could do my 180 minus 53 minus 59 and end up getting 68. So that would be angle 3. All right, we're going to take a look at number 11, another one with angles. So again, it's telling me that we have some mid-segments because these are congruent on the other sides. Okay, so starting out, angle 1, we can get that because we have a linear pair here. Real quick, 180 minus 118 ends up giving me 62. So I know that angle 1 is 62. You could find angle 2 right away because you have a triangle. So you could do your triangle angle sum theorem. 180 minus 95 minus 62, and that's going to result in a 23. So angle 2 is going to be 23. If you have angle 2, you could get angle 3. That's a linear pair. 180 minus 23, that's going to give you 157.
Yes.
Sorry, I didn't really know how to write that. It looks weird. I'm going to put it here. 157. And so now, in order to get these other ones, we've got to use our parallel lines. So my parallel lines are going to be this one and this one. And we're going to use this first as my transversal. And so one of the things that I can see is that angle 1 and angle 5, those two are going to be my corresponding angles. So angle 5 is going to be 62. And then we can do the same thing on the other side. If this were the transversal, angle 2 and angle 4, they would be my corresponding. So angle 2 is going to be, angle 4 is going to be 23. Okay. Now the rest of these are all going to kind of work out the same. So you can see on number 12, I've got my parallel lines. This would be your transversal, which means we are looking at corresponding angles. They have to be equal. So my equation is going to be 7x plus 4 equals 10x minus 11. We can solve that one. And we get x equals 5. And that's all you had to do there, is just find it for x. Okay. Number 13, very similar. Again, you've got your mid-segment here. So it's parallel to this guy. That means I'm looking at my transversal. Now this is a little bit different because if you look at the angles, these are not corresponding. These are going to be those same side interior or consecutive interior, which means that these guys are going to be supplementary. We haven't seen that so far in this lesson. So we have to be aware of what kind of angles that we're looking at in order to set up the correct equation. Combine your like terms. We divide by 16. So we end up getting 13. And again, this one just wanted you to find x. All right, last thing we have to do, again, super duper similar. You've got your parallel lines here and here. That means this guy's the transversal. So I'm looking specifically at these angles and thinking like, what are they? Those two are going to be your corresponding. and corresponding angles are going to be congruent. So your equation is 9x plus 2 equals 15x minus 52. Now you go through and solve. We get x is 9. But in this question, it doesn't want me just to find x. This says find the measure of angle CBF. So it really wants me to plug it in and find this guy. That's CBF. So the last thing I'm going to do is I'm going to that 9x plus 2, where we see x, we'll plug in 9. So I get 81 plus 2, or 83 degrees. That's going to be my answer. Okay. I'm going to rewrite that as a nicer 83. All right, moving on, taking a look at our last one, number 15. So let's mark up our figure. We know our parallel lines. We know this is going to be the transversal. It's asking me to look at this angle and this angle. So we have to really think of what we have. That's going to be your same side interior, which means that they are supplementary. So let's set up the proper equation. 6x plus 1 plus x plus 4 equals 180. Combine like terms, and now we can solve it. So we end up getting x equals 25. But just like number 14, that's not really the answer, because look what they're saying, find RTV, angle RTV. So when I take a look back in my diagram, angle RTV is this angle. So I have to plug it in. So RTV is x plus 4, 25 plus 4. It'll be 29 degrees. That's really my answer. All right, guys, we have reached the end of the notes. I hope you guys took good notes. I would like you to try the 5-1 practice in Canvas. And I will see you guys on Monday.